topics are concurrent computing, task computing, and data intensive computing. So yesterday we covered Web 2.0, in which there was SOAP, REST, AJAX, and Mashup. So today we'll talk about multi-tenant software, and we have covered part of it in our demos. So, but we'll continue to um, you know uh, talk about it a little bit more in depth. So if there's a question on multi-tenancy or multi-tenancy software, then this is the slide or this is the blog you need to look at. Okay. So with this, so today, with this, so we'll start with multi-tenant software. I would request Joel to read it slowly and clearly. So go ahead, Joel.
Hello students, in this vlog we dwell on multi-tenant software as we have known through our virtualization assignment. Multi-tenancy is all about taking one physical thing shared with multiple customers. Cloud implements multi-tenancy at all levels, from hardware to software, from infrastructure to platform as software. Virtualization is an example of using one physical machine and creating multiple virtual machines from it. One processor have multiple cores that can be shared with multiple tasks from different customers. A network device with multiple ports can be divided into different virtual networks utilized by different customers. Multi-tenancy is about supporting multiple entities, and hence multi-tenancy is all about multiple entity support. Multi-tenancy is achieved in SaaS using three techniques. Number one, single schema model. Number two, metadata customization. Number three, multiple schema model. Single schema model. A schema refers to the design in database. It refers to tables, fields, keys that are defined. Single schema model refers to schema of single database used utilized for multiple entities, customers, users. Single schema model uses primary keys and foreign keys to differentiate one customer from another. Example, an Instagram is a single software, but it supports multiple users, customers, entities by having a user ID for each user. When the user accesses the Instagram app, he or she can see only the records, images, videos which has been attributed with his or her user ID only. Metadata customization. Metadata customization technique is dynamic data model similar to NoSQL format, where each customer user entity may or may not necessarily have the same attributes fields associated with them. User 1 may have first name and last name defined in database, whereas user 2 may have first name, last name, and hobby. Every user has its own customized data that is supported by NoSQL database types. Multi-tenancy is provided by the metadata customized technique to different customers even if their metadata is not the same for these customers. Multiple schema model. Whereas single schema model and metadata customized techniques utilize one database, SQL or NoSQL, static or dynamic, for each user. The multiple schema model eliminates the complexity and maintains separate database for each customer. It is similar to microservices architecture that creates a separate service and on its own database for each service type. Multi-tenancy on cloud. AWS cloud provider uses EC2 service to create separate virtual machine for each customer. AWS uses serverless computing model such as Lambda, where the Node.js common platform is managed by AWS Cloud. Each user can create its own Lambda function, which runs on this shared Node.js platform, managed and controlled by AWS. One platform shared with multiple entities, customers, users. Google Cloud Provider uses its App Engine to provide common platforms to run Python, Java, Go program. Google Cloud Provider has its own common data store to which is shared with all users using multi-tenancy software techniques. Multi-tenancy and enterprises. In big enterprise organizations where there is a hierarchy, a CEO has all access to financial reports, whereas a HR person has access to only employee reports. One possible way to manage access is to define access for each user, but such an approach is tedious whenever a new user is added, modified in an enterprise organization. You can instead create data access business rules for different roles instead of different users in the database. You can manage multi-tenancy by simply allowing denying access to roles. You can provide new access to each role. If the user X is an HR role in database, then provide employee report access. If Y is CEO role in database, then provide financial report access. Multi-tenancy is very important feature that enables efficiency, productivity, economic scalability, and it's the core technique used by cloud providers. For more details, go through presentation 1 and presentation 2. Thank you.
Okay. So thank you, Joel.
Yes. Should I
Yeah.
stop the
Yes,
presentation?
you can
Okay.
stop presenting. Okay. So let me present the screen from my side now. Okay. Where we stopped. Okay. Hold on. Okay. So let's understand what has been written over here. It's kind of you all must have already understood what multi-tenancy is by now, right? So the word tenant basically means somebody who stays on rent. Okay. So everybody can see my screen, right? I just want to make sure I'm audible and okay, great, great. So basically, tenant in short means a person staying on rent, and multi-tenant is when you have like multiple people staying on rent in the same place. So basically, a multi-tenancy model is very profitable, right? You are using the same place to which is used by multiple people. So here you may get a rent of rupees, let's say 10,000, 10,000. But when you do multi-tenancy, the rent, now you can reduce the 10,000 rent to maybe, because it is shared with two people, you can make the rent as 7,000 and total income will be 7,000 start to tenants is equal to rupees 14,000. So definitely this is a win-win situation, right? Both. Hold on, somebody. Okay, sir. So this is a win-win situation where the customer is winning as well as the buyer is winning. Now just scale this multi-tenancy model not only into two people, let's say into 10 people. So there are 10 people sharing the same place, or staying on rent in the same place. Okay. So now I can reduce the rent to 5,000, right? And I will multiply this by 10 people, and I will be earning 50,000. You know, so my again this is a much bigger win-win situation. So each person is paying a smaller rent. Now the thing is, it is quite possible now that beyond 10 people is not possible to stay in the same place beyond 10 people. So we can say that this place we can have maximum 10 people staying in one place. More than 10 people now it is not possible. It is full. So the place is full, the house is full. Now everybody gets to a bed to stay, and they can manage. So everything is good. But beyond this, how do we manage? So now maybe these 10 people are staying in the daytime. So there are 10, so I can have a model where 10 people are staying in daytime, right? And 10 other people staying in nighttime, right? So now okay, so now what happens is, even though there is a limit on the number of people that can stay in one house, I am still able to share more people in the same space. So I will reduce the rent to 3,000 rupees per person, and it will be multiplied by 20, and this will become 60,000. So so I have reached the maximum limit of so the largest win-win situation. So what is the customer winning through this? The customer is where he had to pay the rent of 10,000. Now he's paying a rent of 3,000. And where there was only one person using the same place, now there are 20 people using the same place. So why the benefit is the more the number of people that I can share the same resource, the cost of service that each customer has to pay will reduce. And this business model in the industry is called economies of scale. The scale is like which something that grows and something that reduces, right? So in this case, the scale is what? The scale is the number of users. So the more the number of users are scaled, the more better the economy is. The more the people buy, the lesser the the of course, in the real market, when somebody buys more, they increase the cost of the product. Let's say if there are many people are buying, let's say a house in Mumbai. If more people are buying, the rate of the house keeps on increasing. That is not economies of scale model. The economies of scale model is reverse. So as far as real estate is concerned, yes, the economies of scale somehow it's doesn't seem to work there. If more people are buying the house, they increase the rate. No, but in IT field, in the technology field, the problem is the technology keeps getting outdated. Technology, software, they gets outdated very quickly. So this is not the same with the real estate. The technology and software gets outdated. Today you have a technology which can do X task. Tomorrow the new technology will come. It will be able to do X plus Y plus Z. So what is the value of the technology which was there yesterday? Nothing. So the best business model. So the best business model would be what? That today, if I produce some technology, I know tomorrow it is going to get outdated. So I might as well make maximum money in that technology today. And what is the best way of making money using that technology? It is like using economies of scale. So multi-tenancy, cloud, cloud economies of scale, they are all related to sharing maximum resources at least cost. Because as such, so this is what multi-tenancy means as a word, and this is the model that cloud uses, economies of scale. And in cloud, the cost of cloud service keeps on decreasing every with time. So let's now, with this, let's move to the next point. So the next question comes is we check in multi-tenancy on cloud, right? How can multi-tenancy be achieved on cloud? I give you an example where a room is shared with multiple people, right? So in cloud, what is an equivalent of that? In cloud, what do we have? We have on cloud uh, servers, right? Physical servers. These are very um, powerful servers with with a huge hard disk space maybe, and plus it has a huge amount of memory, and plus it has a huge number of processors and cores, right? So this is one of the things which is available on cloud. The other thing is you have all the networking equipments, and this network equipment is available in your data centers, right? Your data centers consist of servers. So so all these servers are stored in data centers. So each data center will have around 50,000 servers. And this networking equipment, they use uh, 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 very good technology, that is, the latest technology in networking, to have the fastest network between availability zones. So basically, each availability zone will have data centers, and there may be one or two data centers in each availability zone. The availability zone is just like some area, some, let's say in Thane there is a availability zone. In Thane there will be two buildings which is like data centers, and in each building there are 50,000 servers, and they are all connected using fast network. So that is how that is what cloud is, physical cloud, we can say. Now, once you have all this, how you can take this resource, right? How can you take all these physical resources, just like we had a room that was shared with multiple tenants, we have data centers and servers and networking and softwares, everything. So right now we are talking about the infrastructure level, right? So how this infrastructure can be so here we are talking about multi tenancies of infrastructure, means the real machines. How do we share a real machine with multiple people? So when we did virtualization assignment, we saw that we can create one virtual machine, two virtual machine. If your machine was very powerful, like it had like 5 TB space, if it had 64 GB RAM, you could have definitely hosted more virtual machines. It would have been more faster. So normally our computers are called commodity computers. So remember this word commodity, computers. This is a computer which which we use. We use our desktops and our normal computers that we use are called commodity computers, which has usually has quad core. Okay, so the physical servers in the cloud definitely cannot be compared to commodity computers because there's a lot of difference in the amount of processing and the amount of computations and amount of networking it can manage, that which it can handle. Okay, so on the cloud basically we are looking at multi-tenancy for everything, whether be it a physical machine, whether be it a platform, or whether it be a software. So this is at the infrastructure level, and now at the next level, we have all these softwares that we use. Right? Let's say example, we have Node.js. So we have where we so we have Node.js, Node.js. We have Java. We have Go. We have Python, and these are programming languages, right? And then we have databases like SQL Server, and then we have Oracle database. These are all relational database. So I hope you understand what relational databases are. Uh, so relational databases are all those databases which uses relational models, which is like it has a table, it has a fields, it has records, which we also call it as rows. It has primary key, and it has got foreign keys relationship. So so relational database model. This is a subject of database. I hope you'll have come across. You'll have studied your database. Relational databases. So I hope you all have studied your relational databases. So I'm not going to go through what relational databases means, but in general, if what we are looking at is we are looking at structured data. It is very rigid structured data that we are looking at. If you want to add a field in relational database, you have to modify the design itself. So that is the characteristics of relational database model. Then you have NoSQL databases, right? NoSQL databases examples are MongoDB, Cassandra, right? And what else? DynamoDB. This is a database on provided by AWS. And so you have databases. NoSQL databases is something which is basically semi-structured. The design is not fixed, or it may be unstructured. So when you say unstructured, it can mean a video file. Now, video file itself, the data within the video file, you cannot read it. What is inside it, or it is not same like reading a text file. or reading a record. So that's why it is more unstructured. So semi-structured is something like we use JSON structures, we use XML. So within JSON, you can, every. So within JSON, and we can, keep as the field names itself. So we can keep. So one record will have, let's say. So let me. Oops, what happened? Hold on. Okay. So I may have uh, something. What's happening? Yeah. So in one record, I may have name is equal to Joe, right? So in this record, the only field which is there is name, but nothing is stopping me from adding, and I take this on top. So now if I have a second record, I can have name is equal to, let's say, Aditya, right? And then I can have another field over here. I can say Aditya's hobby is photography. So this is an example of semi-structured. I can, the structure is not fixed. One record has only name field, other record has name and hobby. So the design is can be modified by simply adding one, lines in your data itself. Your data itself consists, talks about the design. You don't have to create the design first and then provide the data. In relational model, you need to create tables first and then you can add data to it. In semi-structured, unstructured formats, you don't have to create a design first, and that is the biggest advantage in semi-structured and NoSQL databases. So when you say NoSQL means you are basically in relational database models you're using SQL queries, and here you're using NoSQL mechanisms. In a programmatic ways, you can read these files to query. So, but the idea is the platform at the platform level. Then we have the next thing is. So this was about programming languages or databases, and we have operating systems also, right? So in operating systems, we have examples of Windows, we have examples of Linux, right? So there are so many layers in platform itself. So all, okay, I'm sorry, what happened? Did I see somebody? Okay, I don't know, I missed some, okay. Anyway, so this, all these things that I'm talking about, then the question is basically how can I share, all these platforms. So this would be known as multi-tenancy of platforms. So this is where I can take one platform and share it with anybody. So anybody wants to basically, let's say they're using a Google Cloud. So on Google Cloud, they can use a service called App Engine. On App Engine, they can just say, I want to use the App Engine, go on that option, and then say, I want to write a program in Java. So here in this example, you're not installing Java, right? It is already available as part of that App Engine. But this App Engine is a managed service. When you say managed service means Google is managing it for you. You are not installing it. Not only it is managing it, it is sharing it with any number of users. So there may be millions of users across the world which must be writing their own Java program. Everybody is using the same platform. And but can I shift this? Oops. It's not. Right. So the app engine is basically a platform, is a not only a platform as a service, which means it is not only providing the platform, but it is also a managed service, which means Google Cloud is managing that service. You are not in a, this that platform is not only available for you, but it is available for everyone. But at the same time, different people they are not looking. They cannot see each other's programs. That access is not given. That is controlled by the app engine using its own databases. So here this is an example of multi-tenancy of platform. So where we are sharing one platform with multiple users. Hold on. So what we are looking at multi-tenancy of infrastructure, which is the actual hardware. Then we are looking at multi-tenancy of platforms, which is all the softwares that is used to write your programs and run the machines like operating system, database servers, web servers. All these are platforms which can be not only be shared but managed. Okay, so understand the difference between managed and unmanaged. In unmanaged service, you are still availing the service, but your that service is not managed by AWS. You will have to configure it. So if you're using an unmanaged Java platform, let's say you create a machine and you are installing, Java gives you an option to install Java on it. You will have to configure that Java. That Java is not managed by the cloud provider. But there are certain services where the cloud provider comes upfront to you and says, okay, I will manage it for you because you are not very computer savvy. I will manage it for you. And there are many types of managed services. So the cloud provider may say, I have a web server which you don't have to manage. You just simply upload your HTML files. So this such the managed service. So managed service is basically very useful for when your business, when there is more useful for customers. So it's very useful for customers who are not computer savvy, where you want to spend less time installing, configuring, and you want to spend more time coding. So that is when you will go with managed service. A cloud provider will have more better experts on their end compared to maybe let's say our expertise. So that's why one would go for managed service. Um, so through managed service, they provide all these platforms. So we have examples of if you look at uh, AWS, we have Lambda service. So what does Lambda service here does? It provides something similar like App Engine. Just like App Engine supports Java and maybe some languages. Lambda service also supports Node.js programming. and you can program in Java over here. You can program in Python over here. So you simply upload it, and you don't have to create an environment, and you just have to say which version of Node.js you want to use, and AWS will take care of allocating the machines for you, will take care of installations for you, will take care of sharing this platform with other users. So with this, the then we are left with third option, right? The third option is let me remove all this. So we spoke about so far multi-tenancy at infrastructure level, right? Then we spoke about in multi-tenancy at the platform level, and then we have multi-tenancy at the software level. So in software, what options do we see? We see Salesforce.com, right? Salesforce.com is a software where all salesmen, you can. So let's draw one salesman over here. He is one salesman, and there's another salesman somewhere, anywhere in the world, and they are able to access this software. Now, who has installed Salesforce.com? Did the salesman did it? Did the sales company did it? No. Now, just like these two salespeople, they may be belonging to one company, right? It's belong to one company. That way, there may be many companies which is using Salesforce.com, right? So every company will be connecting to the same software. So this is known as sharing the software between multiple not visible. In the same way, platforms sharing is not visible. You cannot see the internals of how app engine has been implemented. It is not, it is a software which is provided to you by this cloud provider. So you cannot see how Lambda has been implemented internally. So definitely internally, they must be using some software like Java, or maybe or Python. They can be, or they may be using web servers, and they may be using load balancing. uh, they must be using so all these techniques, they may be using. The virtualization is at many levels, right? The virtualization is not only at the hardware level, it is also at the platform level. You can say that we are sharing the runtime, the runtime of Java. So it's called runtime virtualization. Then we have operating system virtualization. If you go through our first unit, you will clearly see there are many types of virtualization. Everything can be virtualized, whether be it software, whether be it platform, whether be it infrastructure. So when you say something can be virtualized, it means you can share it with multiple people. When you can share it with multi-tenancy is possible. When multi-tenancy is possible, that category of service can say it is a multi-tenant service. So in cloud, everything is multi-tenant. Infrastructure, platform, software, anything is you can virtualize it, virtualize. So let's now move to the next point. So the question comes, so now here, just remember that we have different customers and different salesmen within each customer base or each business, accessing the software. Uh, so these are called customers. You can say business, or you can say entities. The entity word is more important to remember. So when we are talking about entity, we are talking about an entity that is accessing an actor basically who is involved in your process. So in any process, there will always be entity. There will be a business entity, there will be a customer entity, and there may be government entity. So entities are actors in the system which work together to which work together to run the system. So government is an entity which works with multiple partners, to run a system. A bank is a entity which partners with Mastercard and Visa entities, to run the business. So entity basically are any actors. So when we talk about multi-tenancy, we are in a way talking about virtualization, but we are also talking about multiple entity support, because if you can support multiple entities in a single go, then that is what multi-tenancy is about. That is what virtualization is about. And so these are all interconnected. They are not separate over here. When you talk about, so now we'll look, so yeah, maybe we'll talk a little bit about virtualization here. We've already gone through in the unit one, but we may talk about it here a little bit. So virtualization, as I said, at an infrastructure level, you may have let's say a hard disk. So hard disk is of 1 terabyte size. And if you remember, when we created a virtual machine, we said we want 10 GB for, one virtual machine. So in this way, you can, share the storage, that has been provided. Then processor level, this is where how is a processor shared. So this is where you have to understand what cores are. Cores are basically a core is an executing unit of a processor. So how does a core processor, how does a dual processor, like which is usually available on most commodity machines, how does it look? So this is a processor. Think about it. So inside this, there will be, a core. So this is a processor. So in earlier days, this technology was not available, and but now the modern technology or the modern processes, it is based on core technology. So this is a dual core technology. Now what is a core? It is, as I said, it is an executing unit, but for you think of it as a processor within a processor. So we are looking at a multi processor architecture over here. So this is a physical, executing unit, which within a processor. So if there are let's say two programs running on your machine, okay? So let's say let's draw your machine. Okay, so this is a machine on which there's a processor. Within the processor, there is cores, and so two applications. Let's say your Word is running. Okay, your Word application is open, and let's say your Paintbrush application is open, and so this Word application operating system, usually the control of all your physical resources on your computer, right? This Word will be assigned this core. So which means this core is fully assigned, or one processor you can say has been assigned to one application over here. Another core has been assigned to this application over here. So in this way, two applications are running at the same time, and so this is called multi-processing. Okay, so there's a difference between multitasking, multi-processing, and multi-threading. So we will dwell more on this when we come to concurrent computing. But in this example, this is not multitasking, this is not multi-threading, this is multi-processing. So remember this, you need to know the difference. Multi-processing is actually having multiple processes running at the same time. These processes may be running on the same machine, or it may be running on different machines. If it is on the same machine, then definitely there are multiple processing units, which is called cores, which is enabling the execution of multiple processes. So multi-processing, you can also say, is parallel computing. Okay. Okay, so you have multiple processors. So what is this got to do with multi-tenancy now? Now, just like your operating system, gives shares the same processor with multiple application, thereby enabling parallel computing, thereby improving the performance of a computer, thereby doing more things at one time. Your cloud also does the same thing. The only difference is cloud has very powerful machines, and it may have kind of not dual core or quad core. It can have this cores can go up to 64 to 128. It can go to very high numbers if it is a very modern machine. So we can have 128 cores per processor. So is one person going to use 128 cores? No, this each core is as fast as your commodity processors. So when you're comparing a core in cloud with a processor on your commodity server, you're looking at a very major difference. That one core itself is a very powerful uh, processing unit, and this core is what is when you kind of go on any cloud provider and you say I want a processor. What you're getting is not a processor. What you're getting is a core. These cores are called vCPUs, virtual CPU. Okay, it is not real. processor that you're getting. You're getting a processor within a processor. So that is what uh, cores and multi-core technologies. It is directly related to multi-tenancy, and it is also this kind of it's called virtualization, right? It is a virtualization of hardware. So here we are looking at only one machine with 128 cores, and but in any data center. So as I said, right, there are around 50,000 in one data center, and in each availability zone, so one availability zone will have maybe two or three data centers. So data center is just like building, which has all the servers in it. So you have to maybe you can look up for an image of how the data center looks like. It is consisting of racks and networking cables and everything. And each region has one or two, two or more availability zones. Right, and there are around more than 20 plus regions across the world, and they're all interconnected using network cables, fast network cables. So if you now using this data, you can definitely get an idea how many servers are running, and each server I said is we can have as many as 128 cores in each server. So can you imagine how many cores are running, and uh, you can share all these cores with multiple customers. So when you are creating a virtual machine, you are actually also telling how many virtual CPUs you want. You may say, I want 2 cores for my application. I want 4 cores for my application. It depends on what kind of performance you want from your application. If you have a very heavy application which processes a lot of data and you want it to execute very fast, then definitely you have to go with more cores, right? More cores means more tasks can be done in one shot. So all this will come up in your concurrent computing, and you're going to look at basically all of this in the at the end of this unit 3. But the idea is multi-tenancy is also achieved at the processor level by providing and sharing cores to the relevant customers and entities. So remember the word entity, that which is a customer. So this is so if there's a question on multi-core processing, remember all these points, okay? And there, some of the slides will have a difference between, one of my slides, if you go into presentation, will actually tell you the difference between a core and processor, all those points and benefits. So then at network level, how do we, do the sharing? So network level, if you notice, it is made up of routers or switches, right? And if you had a look at a router and a switch, it will look something like this. And they have plug points, where you can put in your network cables. Just showing you all the, this is a physical network device. You can see it is a router or a switch. And this will keep going on. So you can have maybe 64 switch, ports, network ports on this. So this is one network device, physical device, okay, not even virtualized device. It is a physical device which we are looking at. So dot, and it will continue. And this is one device. And that way, we don't have only one router, but we have many routers that is used in the cloud. So how multi-tenancy is achieved over here, right? So how do you virtualize this network? So we have something known as VLAN, where, so you need to understand networks for this. So you can say, hold on. Okay. I hope everybody can see, right? Okay. Yeah. So in this is a network device, right? In this network device, each port you can number it and say this is number one, this is number two, and this goes to, let's say, number 64. So now, does this mean this one device is for only one user? Ideally, yes. Means you cannot give it to multiple users. If you want to be part of the network, then you need to all be using the same device, right? If one plug you're using in point one, then another plug in point two, so one and two can be can see each other. They may have different IP addresses and different MAC addresses, and they can see each other in network. But what is VLAN? VLAN is basically taking the device and maybe creating a network, a virtual network, you can say, using physical ports. This physical port in one virtual network, you may have port number 1, 5, and you can say 60 and 64, right? So you can create a virtual network, maybe using 4 ports on this particular virtual device. And you can create another virtual network using physical ports, let's say, which is number 2, 4, and whatever, like 40. Virtual network, physical ports, 2, 4, and 40. So which means one device, one network device is again shared with two different customers on two different networks, where one network, virtual network, is not connected to another virtual network. Now you can also imagine a scenario where you have many such devices, right? Network device. So you have one device over here, and this is another device over here. So this is device 1, let's say, and this is device 2. Now, if device 1 is somehow connected in the cloud, they have made sure all these devices are connected to each other. So let's connect this device to this device. And then you run your program, your virtual LAN program on this. Now you can choose your ports. Now, certainly there's no 64 ports that you can work with. There are 128 ports that you can work with. That 128 ports, you can, share it with multiple customers. So this is how virtualization is possible at network level. But as I said, wherever there is virtualization possible, there is multi-tenancy possible. And virtualization is possible at the infrastructure level. You can virtualize a network, you can virtualize a processor, you can virtualize a storage, you can virtualize memory, you can virtualize, you can share an operating system with multiple people. So again, you can virtualize a software. So virtualization is available everywhere and it is directly connected to multi-tenancy. But the question is, how do we know where do we store all this 1, 5, 60, 64, 2, 4? So somewhere we have to store this information, right? You are kind of creating, you have to know which one belongs to which one, who is having access to which one. So that's why we have this multi-tenancy. Tell you some form of database techniques, right? Here we have three different techniques of doing multi-tenancy, which is one is schema model, one is metadata customization, and another one is multiple schema model. So now that we know, how multi-tenancy is achieved at the lower level, but at a higher level, how is a different story. So you have to have some databases internally to manage all this. So these are the three techniques that is used, and there is. So we'll talk about these three techniques for now, and so let's go on to our next point. So what is single schema model technique? Multi-tenancy, right? It's a multi-tenancy technique. How do we achieve multi-tenancy using single schema model? So whenever you hear about schema, we are talking about a design, which how have you designed, what is the schema of your database schema. So we are talking about that. So at a very high level, definitely where if you have dealt with databases, relational databases, hold on. Okay. When we are dealing with relational databases, you may have multiple entities, right? Multiple customers. So how do you manage multiple entities in the database? You will have a user ID. You will have a then you will say this user ID can access. You will have a virtual machine ID. Which virtual machine it can access. It can have a network ID, which this user ID can use which network port. You can have all this kind of database definition in your schema. And so in this databases, let's say you have rows, and the first row has got one virtual machine, let's say VM1 and NP1. Then NP1, like network port 1, NP2, something like what we defined in the previous, like 2, 4, 40 port numbers. So you can define these numbers over here in the relational databases. So you have user ID 2, who's using VM2 and which is using ports 4 and 5. So what are we doing? We are using a simple database relational model to differentiate between one user and another user. So we are using primary keys. We may use foreign keys, just like we manage databases for our applications. We are also using databases to manage our customer base for on the cloud. And you may have tables and so forth. So this is what single model is all about. But the thing is, let's say, as you know, relational database models are rigid, right? They you have to, if you have to add another field, you cannot do it at runtime. You have to we have to change it at design time, and then then you can use it at runtime. So the design has to be modified. When you say design has to be modified, means schema has to be modified. And so let's say now this network, this user ID, let's say I wanted some fields, some specific fields is there. I wanted to store Aadhaar card number suddenly. The government said for all customers that you have on your cloud, I want an Aadhaar card ID. Now, this Aadhaar card ID is applicable only for Indian users. It is not applicable for people in US. So for people in US, there may be no such condition, or they may say, I want a social security number. So how do we, suddenly manage the different attributes? You cannot have a common database for all the users, right? Some users will have some specific attribute which is very specific for that users. So we can use metadata techniques over here, metadata customization. So in metadata customization, what I can do is I can create a separate table called, let's say, social security information. But this will not contain social security information for all the users, right? Because social security is applicable only for people in US. If it is an Indian user, I may have a Aadhaar card information database. Oh yeah. Tomorrow, if some other country comes in, and let's say China comes in, and China says, I want all the thumbprints, or face recognition images of all my customers. So you can create a special separate database for China. I want face recognized images for every customer. So each row is associated. The metadata, that is, the metadata means data about data. Okay, this is this is how you understand what data about data. That is what is metadata. So each row which is in the structured format will have a different, let's give me a different color, maybe, may have a different metadata associated with it. Row number 1 has different metadata, row number 2 has different metadata, and then maybe row number 3 has different metadata. So what metadata customization helps you? It helps you to be flexible. If tomorrow, because cloud, once they have designed, they cannot keep on redesigning everything, keep on changing the design every time. So metadata customization technique is anytime you need some specific information about which is very particular to particular range of customers, you create a metadata base for them. So metadata base. So tomorrow I want to know all the US customers. One way is digging into this database, metadata database, and metadata will tell me, this metadata I will tag it as US, let's say. So this is US, this is India, and let's say this is China. So even before I access the users, I may not have to search for the actual data. I may be making a search based on metadata. So I may search for metadata, and that will improvise my search. If I want to search only US customers, then if I'm operating in US zone, maybe I have to just look at the metadata. The metadata will lead me to the actual data. So that is what metadata customization. Now let's look at the third technique. So remember, these database techniques are used to manage all your cloud users. So ultimately, it comes down to your database operation, the way we manage our databases. So if you're using a NoSQL, so again, right, so this in relational, it is fixed. Here it is not fixed metadata. So here is where your NoSQL can be very useful because it is it is semi-structured. Means you don't have a very fixed structure. It is partly structured, yes, but it is not fixed for everyone. For everyone, each user, the structure may be different. And so the third technique is multiple schema model. So when you say multiple, as I said, what is schema? Schema is design, right? So let me say schema is equal to design. So when you say multiple schema means you're talking about multiple design, you're talking about multiple databases. So in case of multiple schema, you're creating a separate database. Hold on. So you're creating a separate database for each customer or for each entity. So so you're not creating one database which is shared by with all the one database for all customers. You are having customer one. So this will be customer one. In this customer one, he may be using virtual machines over here. He must be using some networks over here. He must be having some metadata associated with him. So but it is not this database is not mixed with any one other database. So every customer will have its the cloud will manage each customer separately using his or her own database. It is a one-to-one mapping, you can say. So tomorrow customer one says, I don't want to use cloud service. It is so easy now to delete or just to maybe archive this record, right? Just to put it as a backup and remove it from the system. It is so easy because we have created a separate database for each customer. So we now in microservices that we assignment that we did, we created three different services, but each service had its own database. So this kind of architecture is very close to microservice services technique, where each user is having its own database. One user's operation does not affect the other user's operation. So all the individual users are managed separately. So this is what multiple schema um, design is. I think what is that? Example, multiple schema model. So cloud may use single schema model, may use metadata customization model, or may use multiple schema model. So in this multiple schema model, as I said, you will have many databases similar to microservices, where each database is serving one customer. Okay. So let's. So there we'll mention over here, right? Single schema model, metadata customization model, multi model. So there's another tech, where you can generalize, everything at a very high level, which is I don't know whether it is required, but let's see. So you can have there are some data access techniques, Um, which you can design your database in such a way that it is much easier to manage using rule engines. So what are rule engines? Okay, so rule engines is like you can define rules in the database, and so the rule in the database can be um, if uh, if customer equals India, and if region is equal to China, then access is not allowed. You can have this kind of rule inside your database. So which means Indian customers cannot access China region. So this is a rule which you can manage. So and the rule engine, so any access is driven by the rules engine. It is not, you cannot directly query the database. Now this data will be actually stored in some other database, right? So you'll have another database which basically only has a list of all customers. So it will have a customer name, it will have a country, you know, it will have services available to him, virtualization service or whatever service, platform service, infrastructure service. All this will be stored in one database. But the rules for this is stored in rules database, and rules database is driven by rules engine, right? So anytime anybody is trying to access any service or any information in this database, it has to get an approval from the rules engine before you make a query. Let's say, for example, I make a query something such as select star from customer where country is equal to China. Now maybe this access is not supposed to be given to Indian customers, right? So maybe only China government wants to have access to this information. So one way of controlling this database is always have a separate implementation of a rules engine, have create a rules database, and you can always add and modify rules in this database. You control this rules database or rules engine, you control the entire software. So this kind of technique is called data access techniques, which is used in bigger enterprises where there are a lot of employees. Now, different employees may have different roles. A call center person should not be able to steal the data and sell it somewhere else, right? Or it should not be able to read the financial report. A CEO must be able to see the financial report, but a HR person should not be able to read the HR reports. So one technique is just embed the rules within the database, but one another technique is separate the rules from the database. The rules, so you control the rules, you control the database. So this is one of the techniques that is used to manage multi-tenancy also. So ultimately, multi-tenancy, when you have to share it with multiple customers, you need to manage the customer's information in using some multi-tenancy databases techniques. Okay. Okay. So with this, we have kind of touched upon multi-tenancies, and we can so this is all for today. I feel we should not, I think we can continue on the next topic maybe next time, but is there any question um, on any of this? Sir, his lecture getting recorded. Tariq's question. Oh my goodness, I forgot to record the lecture. So sorry. Somebody should have reminded me in the beginning, right? There's so many things I'm doing in the beginning. I forgot to record. So sorry. But your yesterday's lecture is recorded and today's lecture is recorded. It's even I lost an opportunity. Okay, is there anything else? Any other question? Anyone else? Can you please respond? Are you all there? Okay, great. Yeah, so today's lecture will not be available as a recording. And unfortunate, I'm so sorry. Even I'm feeling bad. I forgot to start uh, the recording. I was so tired, you know. So this is the blog. So as I've been sharing all these blogs, the ideal way to use this blog, then the presentations is basically has more detail on it, more diagrams in it, and you can whatever. So let us look at the questions maybe. Let's see what questions are there. These are all your question papers. Somebody should have told me now to record. So when should have spoken up says please record. I would have started a recording. So here there's one question, what are multi-core processors, why they are used in cloud computing, right? So you can mention all the points that we mentioned, which we spoke about today. Then we have another question, explain virtualization as a mechanism to achieve multi-tenancy at a system level. So when we're talking about system level, we are talking about the infrastructure level, okay? We spoke about three different levels, right? We spoke about at system level, we spoke about how multi-core technology is used, how virtual LANs are used, how storage is used. All this is at infrastructure level. Yeah, so you can definitely see there are two questions which is related to whatever we spoke about today, and this is like 12 marks. Is there any other question paper? Let's look at this. I think it's the same. So it says again, there's a question, right? Explain virtualization as a mechanism to achieve multi-tenancy at a system level. So this seems like a common question which is asked every year. So remember all the points that we discussed today, and there is a blog, there's a presentation. If you have to, so yeah, so that's it. So next lecture, sorry. Uh, Shabir, what are you looking for? Books means I didn't understand which book you're looking for. Reference books, uh, you just look at the presentations. It will presentations has got everything basically. Whatever is there in the reference books, it is when is there in the presentation. So I would say, have a look at the presentations, right? So here, first of all, you need to refer to the blogs. Now, this all these blogs are there. There are 20 for unit 3, unit 1 and unit 2, there are 26 blogs over here. In this each blog there is a link to the presentations and videos. Okay, so here you have everything over here, so you need to refer to this link, the links that I shared on this. If you multi-tenant software, you see there's a presentation. If you click on this presentation, the presentation will come up. So you have a, so all this is from your books itself. And next lecture, I think we'll have it on next Saturday, Sunday, not during the week, just to enable people who are working. So we will continue next Saturday, Sunday. We might, we'll have. Let's see if we want to do cloud platforms, or but most likely we'll be touching on cloud platforms and concurrent computing next week. And then one more week we'll spend in task computing and maybe data intensive computing. So let's see how it goes. But the next lecture is next Saturday, Sunday, same time. Next lecture is next Sunday at 3 p.m. Is there any other question anyone has? Okay, so with this we'll wrap, and thank you everyone, and have a good evening. Bye.